Hi, welcome to lecture 15. In this lecture, we'll be completing the task and I'll be talking about overflow condition at the end. So the task was to sum the first 1000 integers starting from 1 using while loop. So we have two variables. One is the number itself, the 1000 integer numbers, and the second is their sum. So both of them, if we initialize them, because they are whole numbers and the numbers are in itself integers, and their sum is of course integer and the whole number, so we initialize it using int. So call it sum, and the other one call it number. And now this is the declaration part. Declare. Okay, the next stage is to initialize them. So sum is of course 0 and the number will be started from 1. Perfect, we have initialized them. Now use while loop. So while the condition is that number, and the condition is number is less than equal to 1000. So if this condition is true, because we want to loop it starting, so we want to start the number from 1 and we want to loop it to the condition that it is greater than 1000. So unless so the point where it is less than or equal to 1000, so this block of code inside these curly braces, these braces and curly brackets will be executed even 1000 times starting from 1. So what are we doing here? Here we are adding the integer to the contents of sum. So sum will become, sum is equal to sum plus number. So in the first loop it will look at the condition, because number is equal to 1 is less than equal to 1000, so sum will become 0. The first value of sum is 0 plus 1, which is 1. Now in the next step we want to generate the next integer by adding 1 to the integer. Now number, I want to update the number. If I do not update the number, the result will become infinite, the loop will become infinite one. So this is what I was talking about, that I initialize the number, whatever the condition is. Then I created a condition, and now I'm incrementing and changing that variable number on which the condition is based. So after so number has become 2. Now it will look at the condition, 2 is less than equal to 1000. It will come back. So the sum was 1, and now the sum 1 plus the number is 2. 1 plus 2, it has become 3. The new value of sum is 3. Now the number will be updated from 2 to 3, because 2 plus 1 3. It will again, 3 is less than equal to 1000, so sum will become, sum was 3, so 3 plus 3, which is 6. So this process will continue, and will continue to the point where number is equal to 1001. When the number is 1001, so it will get out of this while loop. So when it is get out, when the whole process got out of while loop, we want to output. What do we want to output? We want to output the sum of the first 1000 integers from 1 is from 1 is, and then we want to output whatever the sum is. Okay, perfect. So this is done. Okay, this is done. If I execute it, compile it, so I have to save it. So I save it by the name of integers. Okay, I saved it. Now if I go to command prompt and call for integers, so the sum of first 1000 integers from 1 is 500500. Now this code is done, but now I want to talk about the overflow condition. So the overflow condition, we can change the condition that that the number is less than equal to 1000. If we change it to 10,000, so it will be summing the integers starting from 1 up to 10,000. If we change it to 20,000, so it will be doing it to sum from 1 to 20,000. So if we try these numbers, we need to know how far we can go with this limit. We know that integers are allocated a fixed space in memory, that is 32 bits in most PCs, and we cannot store a number which requires more bits than integer into a variable of data type int, because we have initialized it using int as is seen here. So if the sum of integer becomes larger than this limit, that is, the sum of integer becomes larger than like 32 bits can store, then two things can happen here. The first, this program will give an error during execution, but compiler cannot detect such errors. These errors are known as runtime errors. And the second thing is that 32 bits of the result will be stored and extra bits will be wasted, so result will not be correct, so we have wasted the information.